Okay, hello everybody. The first question, I guess, is who is familiar with DBIx class? That's good. Who's used DBIx class? Okay, one or two hands go down. Who's used DBIx class with what they would call a legacy schema? Okay, interesting. Yeah. Hopefully this will help. So there will be live demos, so be prepared. Okay, just a little bit about myself. I work for a company called Give and Gain. They are a non-profit that helps other non-profits, a bit like Kickstarter. And the company has been around since 2001, which perhaps gives you an idea of how their code base has kind of grown over the years. And they're currently in the process of modernizing a lot of their code. I've given a couple of talks at YAPSI EU and London Perl Workshop on how we've modernized the front end. So I've talked about replacing CGI with Modulicious and the internals of our code with Moo and Moose. And I thought it probably would be beneficial to talk about replacing the more back-endy kind of stuff, because obviously we have quite an old database and it's accumulated quite a lot of technical debt. The examples here are taken, they're not explicit examples from what we've done, but I kind of mapped them to something that's a bit more, I would say, interesting, but a bit better as examples. If you go to lejo.github.io/code, you can actually find this talk along with all the examples. And it's a Git repo, so you can clone it. There's a CPAN file, so you can install all the CPAN dependencies, so on and so forth. Okay, so my first introduction to DBIx class, which I'll call DBIC from now on, was about 6 years ago now, I guess. I was tasked with, at the time I was working for a payment service provider that was processing about £10 billion worth of transactions a year, which isn't a great deal in the grand scheme of things, but it's enough that you need to think about the size of your ints in the database and that kind of thing. And they gave me about 4 weeks to rewrite the back end, so no pressure. And I started designing the schema, writing some tests, writing some classes, and obviously I got to the model, and I started writing what was kind of the equivalent of an ORM, and it kind of dawned on me, why am I doing this? I know there's stuff out there already to do this, so I investigated and I found DBIx class. And it seemed like a great thing, so I started using it, and it certainly helped hit that 4-week deadline. And one of the big things was not having to write so much SQL within my model classes. Because a lot of the queries were pretty trivial things. Select this from that, join this to that, etc. And I don't have an aversion to writing SQL, but if you keep on writing the same SQL again and again and again, it gets very tiring. And often you will find that you start with some trivial SQL and it can grow a bit. So you really want something that can handle that for you. The main concern is not leaking the abstraction. That's a quote from Ovid, I think, who was quoting Joel Spolsky. You concentrate on the business logic, and you encapsulate the business logic, and you don't leak that into things upstream. If you have, for example, if you're using a web framework, you keep everything to do with the database underneath. You don't leak that into the controllers, which will pay dividends in the future. I think one of the key things is to say that DBIx class is often thought of as a ORM, but it's not just an ORM, it's kind of a general purpose toolkit. You don't have to use it in a prescribed way. It's got a lot of useful features that you might find beneficial, certainly if you're dealing with a legacy schema. And of course, other ORMs are available. So just to expand a bit on the model, a key thing to say is I think that the ORM isn't your model. It helps your model. I think the term model is quite overloaded, but when I think of a model, I think of something that encapsulates the business logic and speaks to a data store. Whatever that data store is up to you. Traditionally, it's going to be a database, but it could be a third-party service or a flat file or anything like that. And obviously, the modern approach to writing web apps is to have this model view controller structure. And it's a little bit misleading in that we seem to give the same size to each component when really your app tends to look more like that. You have a fat model, some views, and very thin controllers that wrap your model. And what you have then is you have perhaps an ORM or something else that will aid your model classes. And as I said, the key thing is to abstract talking to the data store away into the model. You don't want to be calling your database directly from your controllers within your web app, because you're tightly coupling yourself to, one, your ORM, and two, in a way, your data store. So for example here, I'm using the example of I tried to think of a bit more interesting example than a CD database or something. Can everybody see that okay? Yeah?
Make it a little bigger?
And maybe make it a little bit, yeah, let's make it. Oops. Reveal up. So yeah, basically what this is instead of, this is a call to DBIx class, which is calling a result set, which gives you the information back. This is basically a Perl class, a Perl module that wraps that, and we are calling that instead of calling DBIx directly from the controller. And just to give you an example of that, let's go here. So that one is a bit bigger. I assume everybody can see that one. So that's just calling my model class. And the useful thing is obviously, because we can use modern Perl techniques, we can actually add type constraints. So we get slightly more useful error messages if things go wrong. And we can do things with those exceptions. We can have different kinds of exceptions that we can throw into the controllers. So we might want to say, oops, something is going badly wrong in the database here, we'll throw a 500 server error. Or we could, in the model classes, say, well, these are params that have been passed in and not quite right, so we can throw a parameter exception and that can return as a 400 or something like that. So again, we've got that loose coupling. And just to expand on a legacy schema, how we maybe define that is, well, often that's the kind of cynical approach to it, anything you didn't do yourself, but that's not very fair, to be honest. I think more of the cases it's things that have grown organically, which applications tend to do. And often we use technology and we either don't keep up or the technology doesn't support features that we need. So, for example, I think if you're using an old version of MySQL and you're using the MyISAM storage engine, you don't get foreign keys. I don't know if that's changed. Seems like a good idea at the time, and then you grow, and then you find you have technical debt. And I think that technical debt is hard to fix within the database. It's more like a mortgage. It's a very long-term, big payment that you have to pay off, and it makes it very hard to move. And missing a payment can be quite catastrophic. So I thought we'd look at a few of the probably more common examples I could think of within legacy schemas. And I've got a few of them from this book here. I don't know if anybody's aware of SQL Anti-Patterns. I think it's got a great cover. It's a very interesting book. I have it here if anybody wants to flick through it after the talk or anything like that. I think there's about 30 or 40 examples in there, but I'm just concentrating on 3 or 4 here. And that's not to say that a well-designed schema won't have any of these, because a lot of these can be compromises. It's not necessarily a bad thing to do one thing one way and one way another way. So the example I came up with was a ski resort. The company I work for is actually based within the Swiss Alps in a ski resort, and I thought, well, let's see if we could actually model that as a database schema. And I just quickly hacked something together that I think correctly models a ski resort. And a few hours after doing this, I realized actually this is completely wrong in some respects. And I think that's the way that we can end up with technical debt in data stores. We have an idea of what we're modeling, and then 6 months, 6 years down the line, things have changed. So I have here a resort table, an installation table, which would be a ski lift, whatever, pieced, a pieced rating, which would be easy, difficult, a pieced installation to link things together, and then an installation type. And it turns out that it's actually not that simple, because it turns out that a resort can be made up of other smaller resorts, and a piece can go into other pieces, and you have these orphan lifts that link resorts together, and suddenly the schema doesn't work. But actually that's not my legacy schema. My legacy schema is that, which straight away you can see has no relationships. And you probably can't see it there, but we're using some polymorphic relationships, and we have some fields that are chars when they should be booleans, and etc. This is purposely simplistic to show the examples here. So one of the things you might want to do is, if you arrive at a company and you see the horrors, you might want to be able to understand those horrors. And one of the tools built on top of DBIC is RapidApp by Henry down there, who's I think given a talk already on it today. I didn't see it. And this can give you quite a nice, clear overview. So I've got an example of running it here. I'm not going to go into any detail about it, but it's just an example to show you how easy it is using DBIx class and a catalyst, I think, to get a high-level overview of what you're dealing with. Let's see what we've got here. And this is just calling, if I cat that first. So it's pretty simple, really.
Well, if it doesn't work, you can blame me.
Yeah. Or I'm probably using the wrong version of Perl here or something. So it's doing its stuff. That looks like catalyst-y stuff to me. Yep. And write some temp files, more catalyst stuff. Okay, accepting connections. It's a good start. So let's see. And it's port 350. Okay, so we have the interface, and we can explore a bit. So we've got, yeah, I can make that one bigger. So we've got an interface to look at the tables, look at any potential relationships. We can edit data. I won't do that here. But you kind of get a view into what you're dealing with. And there are no relationships here, because there are no, I think it's a little magnifying glass when there's a relationship, which allows you to join into other tables. So that's just the first example of how powerful DBIx class can be. So let's go back to here. And what you might find is that you have perhaps some confusing terminology within your database, if it's started as one thing and there's been a pivot, or it's been forked or whatever. But if you don't leak the abstraction, then it doesn't matter, because you have a model class that calls a database, and all the insanity is encapsulated within that class. And you could be querying a table named anything, potato, but it doesn't matter. Everything calling upstream is calling a sensibly named class. We don't have any tables named potato, just to reassure you. I think this is one of the classic signs of a legacy app: lack of foreign keys, relational constraints. And as I said, it was because I think in the past the technology didn't offer that. people didn't think about it, or they had these aversions, they thought they were slow, they don't give us anything, they make queries complicated. But the R in RDMS is quite important. And what we can actually do with DBIx class is we can generate classes to use with our model classes that have those relationships. So this is an example of using DBIx schema loader, which inspects your database and generates a set of result set classes that you can use within your model. Now, if you had a sane modern database with the relationships, etc., you wouldn't necessarily need to use this, because you can just use DBIx schema loader within your model, and each time you load your app, it will load the classes. But because we need to add relationships, we need to generate them on disk and maintain them. So you can see this in the repo. There's a few. It has so many options, but we're just giving it some sensible defaults here: the name of the model class, the connection information, a couple of plugins that we can use. And it will generate something like that, and you probably can't see that, but what we have is we have a package, obviously, and then we just have a description of the table. It describes the columns, it describes their data types, and then there's a couple of plugins that we can use. But the relationships are missing, and that's really where the power of DBIx class comes in when you're using it within your model classes. And we have to add those by hand. And the way we do that is we can actually add to those classes that are generated a description of the relationships. So we have here an example that says, well, this is the resort item table, which is a linking table, and it connects the resort. It connects to the resort, and we say this column in this table connects to this column in that table. This is what would be generated if we had those foreign keys within the database, but we don't, so we have to add that by hand. And that gives us this trivial way of using DBIx class within the model, those two there, without having to explicitly write the SQL to join the tables to each other. If I Control-C that. Just to give you an example of that, what I've done is I've taken that schema that I had there, generated a SQLite database, then used DBIx schema loader to generate these classes, and I've not written any SQL. I'm literally running this search using DBIC, and let's get this here. So adding relationships. So that gives us a trivial way to get the join and the information from the join tables out. You'll notice that there's two ways to do it. The first one, I'm not using the prefetch option of DBIx class. The second one I am. And this is a major benefit of using DBIx class. It's trivial to join tables to one another, and that becomes quite powerful if you're working with several nested tables that happen to not have relationships. You add those to your tables, your result set classes, and it becomes very easy. And we have several different relation types within DBIx class. These are the ones you might want to use. The only actual relationship within a schema is belongs to, because when you define a table definition, you only ever say foreign key, foo references, table bar. You only ever say it belongs to this table. You don't do it the other way around. But DBIc does allow you to do that, largely for convenience. And you have, for example, this many-to-many method, which is kind of discouraged, but it's there if you need to use it. That allows you to very trivially get the many on the other side of the join without having to jump within them. But it's generally discouraged because I think people can have a bad habit of adding metadata to linking tables. So you have your 1, 2, 3 tables with a link table being 2, and you might add metadata there. And using many-to-many makes it difficult to get that metadata because you're kind of leapfrogging the middle table. So you have to bear in mind that information. Do I need it, or is it a pure linking table? And Reba actually asked me to show you that. And the key thing is he's not proud of it. So one of the other things you might find is in a legacy schema is this polymorphic relationships. It's one of those things that at the time seems like a good idea. It seems like an elegant solution. We can join any table to any other table. We can just add a column to say what table we're joining to, and then the linking ID. And it seems like a clever idea, but the problem is you can't actually enforce relational constraints within your database. You push that down into your code. So you pay for it in the long run. Now, how do you fix that within DBIC? Well, actually, you can do that, because when you add a belongs to relationship, you can pass a code reference, and you can say you can have many columns joining to many other columns. And again, it makes that search very trivial. Just down here, we say, well, join this to this, basically. This is a search. We're saying we're looking for any pieces, and we're prefetching the piece table. And again, that's very, very trivial to do. And if you have many of those, you can just add it in a loop within the relationship class, in the result set class. Sorry. What's this one? Using search related. So this is an example of using search related rather than a many-to-many join. As I said, it's kind of discouraged to use many-to-many, but we can use search related, which allows us to jump from any one place to another place. And that's just an example of looping. So I have two columns. I have two tables that are joining to one table through a polymorphic relationship. This is just putting that loop within the result set class to create that relationship. So that's a lot of what you need to do to fix the missing relationships within your database. But what happens if you have column data that isn't great? So for example, we can use some of the features within DBIx class to make that data easier to deal with. So if you're ever dealing with timestamps or date times within your database, you probably want to get back a datetime object, because it makes arithmetic on dates so much easier. There's an example here where I'm pulling back a date column. So this chunk here is basically the call to DBIC, and then this is just the call to datetime. So I'm just subtracting a month from the data that's come back in that column. I'm not having to manually convert it to a datetime object within the model code. It's DBIC's done it for me. And what that does is you can use that to remove a lot of the data arithmetic within your database queries. So you can basically stop using your database for localization and date calculations. If you're an app that's only in one locale, that's fine, but what if you need to subtract 5 hours from the dates you're displaying? If you're doing that in your database, you're entirely coupled to it. It's quite difficult. But if you do have a lot of hairy logic existing within your database queries, you might want to look at one of the helpers. And what this does is, this is by Through that supports all the various different datetime syntax within the different database engines. So obviously MySQL uses different functions, and Postgres and Oracle. This hides that all behind. It makes it very transparent. So that in theory makes it easier to migrate from one DB technology to another. I say in theory, I haven't actually done this, but... And there's another thing we can do with filters. We can fix perhaps columns that should have been one data type rather than another. So I had, in the example, I had a char, which should be a Boolean. We're using Y and N to represent yes and no. Well, it should be a Boolean. And what we can do is we can use filters to intercept that before it gets into our model class. What we're doing here is we're saying, well, if we're filtering it from the storage, so as it comes out to the database, we're saying, well, if it's defined and it matches a Y, then just return a 1, otherwise 0. And you can imagine if that was pushed up into our model classes, every time we're checking that column, we would have to do the same thing, defined, is, etc. So that gets it just into one place. And it's the same when we filter it to the storage, because obviously we have to still support the fact that we have a char column or a varchar column. It does the reverse on the Boolean, right? It's true, so I'll make that a Y before I insert that into the database.
And that'll only work on robot, not on the result set as well.
That's correct. Yeah.
That'll function because it fit me.
Yeah. And there's an example here. One of the anti-patterns in the book is you might have columns that are storing what should be multiple columns. This is a column that has a CSV. So that's, perhaps you could call that poor normalization or just a hack. And when you want to get that information back, you might want to split it into an array. So you can do that using, again, filter from storage, filter to storage. I'm not using text CSV here for brevity, but obviously you probably want to do that. So there's quite a few useful functions, features within DBIC that we can use to do this for us. Maybe you could even manually enforce referential integrity. So if you're passed a list of data here, you could inspect each entry within the array and say, do another query to check, is that actually valid within the database? Obviously that would be a performance hit, but perhaps it might be useful. So if you have a legacy schema and a legacy app, you've probably got some quite hairy SQL queries. Certainly we do, and I certainly didn't want to rewrite them in SQL Abstract because, one, they tend to be, SQL Abstract is great when you have small, simple queries. When you start getting into multiple nested subqueries, unions, multiple and/or within the where, you can suddenly find it's very difficult to maintain. And anybody that isn't familiar with SQL Abstract syntax will look at that and just not have a clue. It's very opaque. We can actually use raw SQL within DBIx class. We've got quite a few options here. So we can just go down to the low-level database handle, which is probably the simplest way to do it. The suggested way to do that is to use the DBIch do method, because you'll get DBIx's internal exception handling, which will catch things for you. You can actually get to the raw DBI handle, but that's generally not advised. One thing that I find quite useful is virtual views. So these are DBIx class result set classes that describe, as it says, a virtual view. What you do is you describe the columns that this query would return, and then you just put the SQL within that result set. So what I'm doing here is I'm saying, right, it's a virtual view. It has this column is returned, and this is the SQL that we run. And you'll notice that we have a bind query, a bind param there. Now you can imagine, obviously this query is very trivial, but imagine if you have a 100, 200 line SQL query here. This isolates it to, again, one place. Makes it much easier to test, much easier to refactor, and so on. And running it just becomes another DBIc result set, so you can just call it with your bind params, and you get an object back. So you're refactoring a lot of what would be in your existing code, running that SQL, creating your objects or whatever. One of the downsides, perhaps, is that virtual views use bind params, so they're not as extensible as other DBIc searches. But what we kind of discovered is we had a lot of these very complicated queries for generating reports for charities and things, and there would be several subtle variations of them. So in one case, they wouldn't put this bind param in because they weren't interested in this particular type of report. But the bulk of the queries were always the same. It's just a few binds that we were adding. Well, virtual views are just Perl modules, so we can trivially extend them. So what I'm doing here is I'm taking the previous example and just concatenating on the SQL a like query. So we're reusing a lot of the code there. And just to give you an example of that. So this is the first query, which returns me a list of. I give it a list of pistes, and it gives me, say I'm a beginner skier and I want to know the easy piste. Well, that gives me a list of the easy pistes. And if I so it's running the virtual view there. And again, the only SQL I did here, well, obviously I had to write the SQL because it's a virtual view, but that's within that result set class. And I extended that by showing you the example there, where I just concatenated onto the SQL a like clause. If I say maybe I want an easy piece, but I want to avoid any with lakes, where I can just, as you can see, it's the same query again with just an extra bind param. Now imagine you have a very convoluted SQL query that's only slightly different from another convoluted SQL query. This becomes quite powerful. And there is another way to do it. Ovid has this module on CPAN, DBIx class report, which generates a virtual view class on the fly. And I think I didn't bother copying and pasting the synopsis there. But as you can see, it's just we create our SQL and then we pass into DBIx class report. And if you look into the internals of this module, it's just creating a virtual view class. So if you want to do it on the fly, it's easy. I think the problem here is you're still pushing some of the DB logic up into your model class a little bit. So it's not, I don't think it's as well factored as having a single virtual view class. But it's the options there should you need to do it. Okay, so I think that's 2 or 3 of the classic signs of a legacy schema. And if you do start moving over to DBIC, you have to be aware of the power of DBIC, and obviously as with great power, etc., etc. It's very useful to use some of the debugging and profiling flags within DBIC. So it offers these environment variables here that we can use to do some tracing of the queries. You can see exactly what SQL is being run against your schema. And this here is a chunk that I usually stick within the schema class, the base schema class that is generated. And what this does is when you run, this is what you will get by using the DBIC trace environment variable. You'll get a nice pretty printed output of your SQL with the binds. What I tend to add is I add a little bit more debug before. I print out this result set which tells us the table and actually where it's coming from. And this becomes very useful when you're doing looping and multiple nested searches, because what it will do is it will print out the result set every time you're calling DBIx class result set. What you can use that to do is to find places where you're not joining with prefetch. One of the big powers of DBIC is to be able to grab everything you need at once, instead of selecting your row and then going back to the database to get the related row and again to get another related row. You can imagine if you have 3 nested for each loops, suddenly you can exponentially explode on the number of queries that hit the database.
How does the performance compare if you can go to the actual database and create a view, Sybase,
Yeah, I'll get to that. I'll get to that. So that will give you an output of the queries you're running. Now, what I've been meaning to do is I've been meaning to actually write something that will parse that and generate a useful web interface to tell you, look, this is calling the same query n times. You're probably missing a prefetch here. And just to get to that, you need to prefetch. The power of DBIC is that you can join things in advance and get that data all at once. It's the bottleneck in speaking to your database is generally going over the network, coming back again, assuming your indexes are correct and your database isn't something horrible and slow. You don't want to be going back and forth over the network. You want to grab everything that you need at once, and that's why you need to use prefetch. And you need to obviously test your app with a representative data set where possible, because it's very easy to have a small dev database that only has a few megabytes when your production database is a few hundred gigabytes. Suddenly you can find nasty surprises. And you need to keep your result set classes up to date. So just to go back to the optimization thing, yes, you can put your view within the database itself. I think it's finding a balance. The examples I'm using here, we're trying to loosely couple ourselves to that database. DBIC is written to make it trivial to migrate from MySQL to Oracle to whatever. If you're moving that logic down into the database, then you're tightening that coupling. You might need to do that for performance reasons, and certainly if you're getting to that level of we need to optimize the database queries and we need the database to be as fast as possible, then that's when you start to need to think, do we actually want to use DBIC class? If you're needing to optimize to that level, then you might think, well, is this giving us benefit? It's a kind of scaling issue rather than a DBIC class issue, if you like. So just to kind of summarize, as I said, you want thin controllers and a fat model. You want your business logic and the key logic of the app within the model. You don't want to tie the database to the controllers, to the things that are speaking to the user upstream. And DBIC class is a toolkit. It's not just an ORM. We can define relationships even if they don't exist. It's not necessarily the simple relationships that we would have defined within our schema. We can do other things. We can join other tables to maybe things they're not even meant to be joined against. That's the power it gives you. And we have filters that we can use to fix data. And if you really want to, you can go down into the low-level handle to actually write raw SQL. And there's a lot of other stuff that I didn't cover. There's a lot of useful debugging and logging things, and deploying updates to a database is often quite a pain point. There's some features within DBIC that we can use to ease that. And there's many, many, many helpers. I think I have the helpers up here. So this is some of the stuff that Fru's written to. This goes on and on and on, really. If there's a problem you have, then there's probably a helper to make that easy. And there's loads of other stuff, because if you run that against MedCpan, you get about 100 distributions in the DBIx namespace. So that if you need to solve a problem, there's probably something there for you. And that's it. Any questions? No questions?
There's also a correlated subquery helper
Right.
in the helpers, so that can help you. Like we with our legacy schema, we had a bunch of like n+1 queries where it was like, grab these things and then also grab a count from a related table for each of them. And
Yeah.
the correlated subquery helper
Yeah.
can correlate based on a relationship you've defined, and we just compose those with result set methods.
Yeah.
It makes
Yeah.
it much cleaner, and you get it all done in one request.
Yeah, one request. That's the amazing power of it. It's one call and you have everything you need. Everything's in one place. It makes moving forward so much easier. And we've actually, yes?
Go ahead, finish your...
Well, I was going to say that we updated our site, and this is running on Mojo and Moo, and underneath the hood it's still a 15-year-old database schema with no relationships, and a lot of the column data is quite poor. And just to go back to the performance issue, obviously if you have, am I still connected to the Wi-Fi? Yeah, some of these pages are quite heavy, so because the logic is all encapsulated within one place, it's very trivial to cache that, to put memcache there. You know, call memcached rather than the database. If that's spread all over your controllers and all over the place, it's suddenly very difficult. You hit one of those hard problems. Sorry, you can say.
So this is more of a comment than a question, but this problem domain of missing foreign keys is something that I've encountered quite a lot, and it's anybody who's written, any PHP developer has written an application, they have foreign keys, but trust me, there will be no foreign keys to find in the database. They'll just be doing it in code.
Yeah. Yeah.
And this is actually, you use the DBIC. This is an experimental feature that isn't documented, but there's an option to DBIC meta keys, which lets you specify a file, which you can supply local table dot local column space remote table dot remote column, and
that expands into
a line, and then when you pass that, when you run rapid DBIC, then it will act as though those foreign keys were defined, and then you'll get the little magnifying glasses, even if there's not really.
Yeah. Okay. Yeah. I think a lot of it's because the databases, we kind of come to realize that the technology wasn't maybe not suited, like I said in my ISAM, or there was just an aversion to this. I worked with one company I worked for, they were using an Infomix database, so they were paying a fortune for this database, and I don't think they were using any foreign keys, which is a bit crazy really when you think about it.
I don't think PHP developers know what they are.
Yeah, perhaps. I think one of the criticisms you often hear about ORMs is they're for people that don't understand or don't like SQL, and I don't think that's the case. I think it's actually the other way around, because when you truly understand the power of a correctly designed schema, a correctly designed database, and how easy it is just to point DBIx class at it, it saves you 40% of your development time. It makes it so trivial.
Well, 10 years ago, it was so much easier to scale a web server.
That's true as well. Yeah.
So we had this paranoia in our old legacy code about, nothing must be in the database unless it's absolutely necessary.
Yeah.
And now it's pretty much
Yeah.
the opposite.
There's a lot of work being done there. Yeah. Anybody else? Yeah.
How many tables are in your legacy database?
Not a lot, and when I say not a lot, I mean about 300. So I don't know what other people's experiences are with legacy schemas and how many tables. I've interviewed with companies where they've told me stuff that's just scary. So one case was they were very, I say on top, they were very strict about normalizing, and they normalized it to the point of a different database for every client. So they had over 3,000 databases. So if you're getting to that level of legacy, then I think you've painted yourself into a corner. It's going to be very, very difficult and take a very long time to escape that. And perhaps some of this stuff can help. You can start isolating small sections of it. But if you're dealing with a big ball of mud, then yeah, you really have to look at that and think about it and spend a long time hopefully writing tests against it. And it's, like I said at the start, it's a mortgage. It's not. When we talk about technical debt, this is decades in some cases. Anybody else? Okay, thank you very much.